From time immemorial, we have been called upon to simply believe. To believe in gray-haired authorities, to believe in the tomes in their dusty bindings, to believe in everything that was uttered before us. Today, however, we shall set faith aside, for it is the province of those who are afraid to ask questions. Our province, instead, will be observation, cold logic, and incorruptible common sense. There exists a persistent notion that our world is not an azure sphere flying through the velvet abyss of space, but a stationary, flat disk washed by unknown waters. As if all the countless proofs to the contrary are merely an intricately woven part of a global conspiracy of incredible scale. But let us for one moment put aside the whispers of conspiracy theories and simply look at the world around us, look with an unclouded gaze. Let us look as our distant ancestors did thousands of years ago, and as we can look today, armed with the simplest of tools and the indomitable power of our own minds. We will consistently and meticulously analyze 32 phenomena, each independent of the others, each one unique. Each of them is a question that we pose to the very fabric of the cosmos. And to each of these questions, nature provides the same exhaustive, immutable answer. Let us begin with the first, most visual and irrefutable piece of evidence known to every mariner since those immemorial times when the first tarred hulls touched the salt wave. Imagine yourself standing on the shore of a boundless ocean on a clear, sun-drenched, serene day. Your gaze is fixed on the horizon, on that deceptively sharp line where the blue of the firmament meets the azure of the water's surface. In the distance, at the very edge of visibility, a ship appears, sailing away from you into the open sea. If the world were a perfectly flat surface, like a giant table of polished stone, then this ship, as it moved away, would simply become smaller and smaller. It would inexorably shrink to a tiny point until it disappeared beyond the limit of your visual acuity or dissolved into the shimmering atmospheric haze. The entire ship, from its submerged keel to the very top of its proud mast, would simply diminish in size. But in reality, we witness a completely different, mesmerizing picture, one that is inexplicable within the framework of flat geometry. The first thing to begin disappearing from view is its massive hull. We see the water surface as if it is slowly and relentlessly engulfing its lower part. The ship does not shrink in its entirety. It seems to be sinking into an invisible abyss, disappearing from the bottom up. For some time, we can still clearly distinguish its deck, the captain's bridge, the funnels, and then the masts, which seem to glide along the very surface of the water, deprived of their foundation. And only at the very end does its highest point, the last flag on the mast, vanish behind this invisible yet real hill of water. This effect cannot be explained by any laws of perspective. Perspective makes objects appear smaller, but it does not slice off their lower part while leaving the upper part visible. Place any object on a long, perfectly flat table and walk away from it. It will shrink strictly proportionally in its entirety. The only logical, the only possible explanation for what we see at sea is the presence of curvature. The ship is sailing over the curve of the earth, exactly as a tiny ant crawling away from you across the surface of an enormous orange would disappear over its roundness, and the last thing you would see would be its barely noticeable antennae. This is not a theory, not a conjecture. It is a daily, repeatedly observed phenomenon, accessible to everyone. Now, let us lift our gaze from the shifting surface of the water to the eternal night sky and await a special mystical event, a lunar eclipse. At this solemn moment, our Earth is positioned in space exactly between the sun and the moon, and the gargantuan shadow of our world falls upon the silvery lunar disk. Look closely at the edge of this shadow. What is its shape? Regardless of where you are on Earth, what time of night this celestial performance occurs, or in what phase the moon is before and after it, the edge of the Earth's shadow creeping across its cratered face is always, without a single possible exception, the perfect arc of an ideal circle. When the shadow covers the moon entirely, at the moment of total eclipse, it outlines a full, perfect circle. Now, let us conduct a simple thought experiment. What shape of shadow is cast by a flat disk, say, a coin? It can cast a circular shadow in only one single, strictly defined case, if the light source is directly behind it, perpendicular to its plane. But if you turn the disk at the slightest angle to the light, its shadow immediately becomes oval, an elongated ellipse, and if you turn it on its edge, it will shrink into a thin, barely noticeable line. Our Earth is in constant, unceasing rotation. If it were a flat disk, then during different eclipses, occurring at different times of the year and night, it would be oriented differently with respect to the sun, and we would inevitably observe shadows of all possible shapes on the moon, wide ovals, narrow ellipses, and straight lines. But in thousands of years of documented observations, from the Babylonian priests to modern astronomers, humanity has seen only one thing: a perfect, unchanging circular shadow. And there is only one single geometric shape in the entire universe that, under any illumination and from any conceivable angle, consistently casts a circular shadow. That shape is a sphere. Let us continue our fascinating journey across the celestial vault. If you have lived your entire life in the northern hemisphere, for example, you have been accustomed since childhood to a specific, familiar pattern of stars. You know how to find the stationary North Star in the night's gloom, that celestial nail around which the entire night sky seems to revolve. You can easily recognize the outlines of the Big Dipper and the regal Cassiopeia. Now imagine that you embark on a long, adventurous journey to the south, cross the equator, and find yourself, for instance, in sultry Australia or at the Cape of Good Hope in South Africa. On the very first clear night, you will raise your head to the sky and you will not believe your eyes. The sky will be completely, unrecognizably different. You will search in vain for the North Star. It will be irretrievably hidden somewhere far beyond the massive northern horizon. The constellations familiar to you from childhood will either be visible very low on the horizon, bizarrely inverted as if reflected in a distorted mirror, or they will not be visible at all. Instead, a new, unfamiliar, dazzling stellar pattern will unfold before your astonished gaze, with the bright constellation of the Southern Cross, the nebulous patches of the Magellanic Clouds, and countless other treasures of the southern sky. How is such a thing possible on a flat Earth? If our world were a disk, the entire starry sky would be a single common dome for all, and from any point on the disk, we would see the same stars. Yes, perhaps at different angles, some higher, some lower, but they would all be available for observation. The very fact that the curve of our planet, physically, like an insurmountable mountain, hides entire sections of the universe from us until we travel a significant distance across its surface, is irrefutable, visual proof of its spherical shape. You have simply moved around the corner of this giant ball, and a completely new, breathtaking view has opened up to you. Let us transport ourselves mentally to the distant past, more than 2,000 years ago, to the learned and wise world of ancient Greece, and meet the brilliant, perceptive mind of Eratosthenes. He did not build spacecraft or use complex lasers. His tools were simple wooden sticks, his own eyes, and the unbreakable power of logic. Eratosthenes knew that in the city of Syene, known today as Aswan, there was a very deep well, the bottom of which was fully illuminated by the direct rays of the sun only once a year, at noon on the day of the summer solstice. This meant that at this specific moment, the sun was exactly at its zenith, directly overhead, and therefore a vertically placed stick cast no shadow. But Eratosthenes himself lived in the great city of Alexandria, located considerably north of Cyane. He conducted a simple but brilliant experiment. On the very same day and at the very same hour, he measured the shadow from a vertical stick in his own city. And there was a shadow, not very long, but quite noticeable and measurable. He asked himself, how is this possible? The sun is at a colossal distance from us, and therefore its rays reach the earth in nearly parallel streams. On a flat surface, if the sun's rays fell vertically in one place, they would fall vertically everywhere, and there would either be no shadow anywhere, or it would be the same everywhere. The difference in shadow lengths in two different cities at the same time could mean only one thing. The surface between Cyane and Alexandria is not flat, but curved. Imagine sticking two pins into a flat piece of cardboard. Their shadows from a distant lamp will be absolutely identical. Now, stick them into an orange. One might have no shadow at all, while the other will certainly have one, because it is stuck in at a different angle to the light source due to the obvious curvature of the surface. Eratosthenes went further. Knowing the distance between the cities and measuring the angle of the shadow, he, using simple school geometry, was able to calculate the circumference of the entire Earth with an astonishing, almost unbelievable accuracy for his time. This proof is not just elegant. It convincingly demonstrates that to understand the true shape of our planet, one does not need complex technologies, but only keen observation and a clear mind. And now, let us think about something that seems self-evident to us modern people: circumnavigation. Let us recall the perilous and arduous expedition of Ferdinand Magellan. His ship sailed from Spain, heading west toward the setting sun. They crossed the tempestuous Atlantic, rounded the wilds of South America through the strait that now bears his name, traversed the gigantic, unimaginable breadth of the Pacific Ocean, reached the shores of Asia, and then, after rounding Africa, returned to their native Spain, but this time from the east, from the direction of the sunrise. They sailed continuously in one general direction and returned to their starting point. Try to imagine such a thing on a flat map of the world. Where would you be sailing? To some mythical edge of the world? To a gargantuan ice wall that some theories speak of? And how, upon reaching this edge, could one suddenly find oneself on the other side without turning around? The model of a sphere explains this with elementary simplicity. If you move across the surface of a sphere in the same direction, you will inevitably complete a full circle and return to where you began your journey. It is akin to walking around a soccer ball. No matter which way you go, you will not find an edge. The hundreds of thousands of circumnavigations accomplished since then by sailing ships, steamships, modern liners, airplanes, and even hot air balloons are not indirect, but direct, physical, and repeatedly verified confirmation that our world has no edge. There is only a continuous, smoothly curved surface that brings the traveler home. In the modern space age, we have gained a staggering advantage that all previous generations were denied. We can look at our home from the outside through the eyes of an impartial observer. There exist tens, if not hundreds of thousands of photographs and hours of video recordings of Earth from space, taken over more than half a century of space exploration by various countries, by competing agencies, from automated satellites, from the board of the International Space Station, and during the legendary Apollo lunar missions. In all of these images, without exception, obtained from different angles, at different altitudes and distances, the Earth appears as a sphere, a shining blue globe with swirling white clouds. Of course, a convinced skeptic might declare that all these photographs are a masterful forgery, the result of highly complex computer graphics, and an integral part of an all-encompassing global conspiracy. But let us for a moment contemplate the true scale of such a conspiracy. It would have to include not only America's NASA, but also the Soviet and later Russian Roscosmos, as well as the European, Chinese, Japanese, and Indian space agencies, organizations that for decades were and remain implacable political, military, and technological rivals. It would have to encompass hundreds of thousands of scientists, engineers, astronauts, programmers, and communication specialists around the world. And in all these long years, not a single one of them has let it slip. Not one has presented irrefutable proof of a monstrous falsification. A far simpler, more logical, and common-sense explanation is that the photographs are real, and they show our world as it is, a beautiful, fragile, lonely blue sphere in the infinite darkness. Let us now turn to the fundamental, all-pervading force that shapes and molds our universe: gravity. Gravity is the universal force of mutual attraction between all objects, without exception, that possess mass. When a celestial body large enough, such as a planet or a star, forms from a protoplanetary cloud of dust and gas under the influence of this force, gravity relentlessly pulls all of its material toward a single center of mass. Imagine this grand process. Billions of tons of particles are attracted to each other from all directions, striving to occupy the most energetically favorable, most stable position, which is to be as close as possible to the center. And the only geometric shape that allows every particle on the surface to be at the closest and most equal distance from the common center of mass is a sphere. It is precisely for this reason that our Sun is a nearly perfect sphere. The Moon is a sphere. Jupiter, Mars, Venus, and all the other planets and large moons in our solar system are spheres. They may not be perfectly ideal, being slightly flattened at the poles due to rotation, but their primary dominant form is spherical. To assert that all known celestial bodies obey this fundamental law of nature and take the form of a sphere, while our Earth alone, for some completely unknown and exceptional reason, is a unique exception and is a flat disk, is to completely ignore the basic foundational principles of the entire observable universe. The Earth is not special in this regard. It abides by the same universal laws as its countless cosmic neighbors. Our world does not just hang motionless in space, it continuously rotates on its axis. And this rotation has very specific, physically measurable and observable consequences for its shape. Imagine you are rapidly spinning a soft clay ball in your hands. What will happen to it? Under the influence of centrifugal force, it will inevitably begin to flatten at the poles and bulge, to expand at the equator. Exactly the same thing happens with the Earth. Due to its very rapid rotation, the speed at the equator reaches a colossal figure, about 1,670 kilometers per hour. It is not a perfect mathematical sphere. It is what scientists call an oblate spheroid, or more accurately, a geoid, a sphere slightly flattened at the poles and noticeably convex at the equator. The Earth's diameter measured from pole to pole is approximately 43 kilometers less than its diameter measured along the equator. This is not just a pretty theory. It is a repeatedly measured fact that affects, for example, the force of gravity. It is slightly stronger at the poles than at the equator, because at a pole you are physically closer to the planet's center of mass. The shape of a geoid is the direct, inevitable physical consequence of almighty gravity having formed the Earth into a sphere, and rapid rotation having slightly deformed that sphere, giving it its characteristic shape. There is a strikingly elegant and captivatingly simple experiment that visually and irrefutably demonstrates the Earth's rotation, the famous Foucault's pendulum. In the middle of the 19th century, the French polymath Léon Foucault suspended a long, multi-meter pendulum with a very heavy weight on its end from the high dome of the Pantheon in Paris and set its slow, majestic oscillations in motion. A pendulum, once it starts moving, according to the fundamental law of inertia, strives to keep its plane of oscillation absolutely constant relative to the stars. If the Earth were stationary, it would have continued to swing back and forth in the same direction until it stopped. But all present witnessed a truly astonishing, almost mystical spectacle. The plane of the pendulum's swing was slowly but steadily, with clockwork precision, turning clockwise. In reality, it was not the pendulum that was changing its direction of motion. It was the stone floor of the Pantheon, along with the entire great city of Paris and the entire planet Earth, that was rotating beneath it. This brilliant experiment has since been repeated many times all over the world. Moreover, in the southern hemisphere, the pendulum's plane rotates in the opposite direction, counterclockwise, while at the equator, it does not rotate at all. Such symmetrical and opposite behavior is possible only on a rotating sphere. This is a visual, purely mechanical proof that we live on a gigantic rotating ball. The rotation of our planet gives rise to another global, all-encompassing phenomenon that we observe in weather forecasts every day, the Coriolis effect. Imagine any object moving freely across a rotating surface. To an observer on that surface, its trajectory will appear to be curved. On Earth, this manifests in the fact that global air and water currents moving over long distances are deflected from their original inertial direction. In the northern hemisphere, this deflection occurs to the right of the direction of motion, and in the southern hemisphere, to the left. It is for this very reason that gigantic atmospheric vortices, cyclones, and destructive hurricanes always spin counterclockwise in the northern hemisphere and clockwise in the southern. This is not a coincidence, but a fundamental law of motion on a rotating sphere. On a flat rotating disk, the effect would also exist, but it would manifest completely differently and would not have such clear symmetry relative to the equator. The symmetrical and oppositely directed rotation in the two hemispheres is the unique signature of a spinning sphere. Professional snipers and artillerymen firing at very long ranges must include a special correction for the Coriolis effect in their calculations for their bullets and shells to hit the target. This is not an abstract theory, but a stark physical reality that is taken into account by military personnel and meteorologists worldwide. Let us talk about a technology that many of us use almost every day without thinking about its principles, the Global Positioning System, or GPS. Your smartphone or car navigator determines your exact location by receiving and analyzing signals from several satellites simultaneously. These satellites are not fixed in the sky as if nailed there. They are in strictly defined high orbits and are circling the Earth at a colossal speed. The entire complex mathematical model upon which the GPS system is built, from the first equation to the last, is based on the unshakable postulate that the Earth is a sphere, or more precisely, a geoid with known and accounted for parameters. The system calculates your position based on the travel time of a radio signal from at least 4 satellites in known predictable orbits around a spherical gravitational body. If the Earth were flat, this entire multi-billion-dollar system would be utterly inoperable. The stable orbits of the satellites themselves would be impossible in the form they exist. The very idea of a stable orbit is based on a delicate balance between the satellite's velocity, which tends to carry it off into space, and the gravitational pull toward the planet's center of mass. For a flat disk, The gravitational field would be completely different, and the operation of GPS as we know it would be physically impossible. Every time you use a navigator to find your way, you receive a silent but absolutely practical confirmation of our planet's sphericity. Let us consider the actual flight paths of modern intercontinental airliners. If you look at a conventional flat map of the world, for instance, in a Mercator projection, the shortest path between two distant cities appears to be a simple straight line. But the real routes of airplanes, especially on long-haul flights, often look like strange, illogical arcs. For example, a flight from Chicago to Tokyo does not fly due west across the vast Pacific Ocean, but along a wide arc that passes near Alaska and Kamchatka. Flights from Europe to North America follow an arc that curves northward over the ice fields of Greenland. Why does this happen? Because on the surface of a sphere, the shortest distance between 2 points is not a straight line, but an arc of a so-called great circle. Pilots and airlines, seeking to save precious fuel and flight time, fly exactly along these optimal routes, which on a flat map look curved and long, but on an ordinary globe, if you stretch a string between two cities, turn out to be the most direct and shortest paths. There are even trans-Antarctic flights, for example, from Australia to South America that pass over the icy continent. On most flat Earth maps, Antarctica is represented as a giant ice wall along the outer edge of the disk, and such a flight would be not just long, but physically impossible. The real routes of air travel are a daily, commercially motivated, multi-billion-dollar demonstration that we live on a globe, not a flat map. Let us think about the most fundamental rhythm of our lives, the cycle of day and night and time zones. We take it for granted that when the sun is shining on us, deep night reigns on the other side of the world. When it is noon in Moscow, it is still early morning in New York, and evening twilight is already gathering in Vladivostok. This global system is perfectly and effortlessly explained by the model of a rotating sphere illuminated by a very distant and powerful light source, the sun. A sphere is always illuminated on exactly 1/2 at any given moment. Its continuous rotation causes the terminator line, the sharp boundary between light and shadow, to constantly move across the surface, creating a smooth and predictable succession of day and night for all its inhabitants. Flat Earth models attempt to explain this phenomenon with some small local spotlight sun that supposedly flies in a circle above the surface of the disk. But such a model collapses at the first serious scrutiny. If the sun were such a close spotlight, it would be visible simultaneously from all points on the day side of the disk, just at different angles. We would see it approaching at dawn, growing larger and brighter, rising high in the sky at noon, and receding toward sunset, becoming smaller and dimmer, but never setting below the horizon. However, we observe something completely different. The sun rises from behind the horizon every morning and sets behind the horizon every evening. It physically disappears from view, being obscured by the planet itself. And this is possible only on a curved surface. The very concept of time being different at different points on the planet is a direct and inevitable consequence of its spherical shape and axial rotation. Let us return once more to the grand celestial eclipses, but this time to solar ones. When the moon, our natural satellite, passes directly between the Earth and the sun, it casts its shadow upon our planet. What do we see during a total solar eclipse? We see that the path from which this rare and spectacular event is observed is very narrow, usually not exceeding 200 or 300 kilometers in width. This dark band of the lunar shadow races across the Earth's surface at an enormous supersonic speed, granting a few lucky people minutes of twilight in the middle of a clear day. If the Earth were flat and relatively close to the sun and moon, as some alternative theories suggest, the shadow from the moon would be colossal, covering a large part or even the entire earthly disk. A narrow and rapidly moving path of shadow is the direct and precise consequence of the complex celestial geometry of three spherical bodies located at vast distances from each other. The cone-shaped shadow, the umbra, from the spherical moon falls upon the convex surface of the spherical Earth, creating a small, constantly moving elliptical track on it. The study and prediction of the exact paths of the lunar shadow with an accuracy of meters and seconds for centuries into the future is one of the greatest triumphs of celestial mechanics, based entirely and completely on the model of spherical bodies orbiting in space. Let us consider the unique, almost surreal phenomenon of the polar day and polar night. In regions located beyond the Arctic and Antarctic circles, there are long periods when the sun does not set below the horizon for months in the summer and does not rise above it for months in the winter. In the summer, the sun simply circles along the horizon, never setting, creating an endless day. In the winter, a multi-day chilling darkness reigns, broken only by the light of the moon and the polar auroras. This phenomenon is absolutely, categorically impossible to explain using the flat Earth model with its local spotlight sun. How can the same light source illuminate the center of the disk, the Arctic, 24 hours a day, and then leave it in impenetrable darkness for a full 6 months? On the other hand, this phenomenon is perfectly, simply, and elegantly explained by the model of a spherical Earth whose axis of rotation is tilted relative to the plane of its orbit around the Sun by about 23½ degrees. It is precisely because of this tilt that the North Pole looks toward the Sun for half a year, receiving continuous illumination, and then for the other half year, it turns away from it, plunging into deep shadow. The exact same thing happens with the South Pole, but in the opposite phase. The polar day and polar night are not some anomaly, but a direct, rigorous, and inevitable consequence of the axial tilt of a rotating sphere journeying along its orbit. In our time, the era of high technology, the curvature of the Earth can be measured directly using modern and high-precision instruments such as powerful lasers. Demonstrative experiments are conducted in which a laser beam is aimed perfectly horizontally over a long distance, for example, across the perfectly smooth surface of a calm lake or a long shipping canal. At a certain distance from the laser source, a target with markings is set up. If the Earth were flat, the beam, aimed perfectly parallel to the surface, should hit the target at the exact same height at which it was emitted. However, in practice, time and again, the beam always arrives at a point that is significantly higher. Over a distance of several kilometers, this deviation already amounts to tens of centimeters or even meters. This happens because the beam travels in a perfectly straight line through space, while the surface of the Earth beneath it curves and smoothly drops away. This is a direct, purely instrumental measurement of curvature, which with high accuracy confirms the calculated values for a sphere with a diameter of about 12,742 kilometers. Such experiments, conducted by independent researchers in different parts of the world, have time and again irrefutably confirmed the presence of curvature. Let us consider the type of communication without which the modern globalized world is unthinkable: radio communication. Radio waves of certain lengths, especially in the shortwave band, have the amazing ability to travel over enormous distances, literally circumnavigating the globe. This is what allows amateur radio operators in Europe to freely communicate with their counterparts in distant Australia. How is this possible? It is partly explained by the repeated reflection of the radio signal from the ionosphere, the charged upper layer of the atmosphere that acts as a gigantic natural mirror. But the curvature of the Earth itself also plays a key role, creating conditions for the propagation of the so-called surface wave, which follows the planet's curve. On a perfectly flat Earth, long-distance radio communication would only be possible within the line of sight, like the beam of a flashlight. The signal, encountering no obstacles, would simply go straight into space. The variability of radio waves to follow the planet's curve, allowing us to communicate with people on its other side, is another important practical confirmation that we do not live on a boundless plane. Now, for two subtle but fundamental astronomical observations that confirm not only the spherical shape of the Earth, but also its motion through space. The first is stellar parallax. If you hold a finger out in front of you and look at it alternately with your left and right eye, you will see that the finger appears to shift against the background of distant objects on the wall. This is parallax. The same thing happens with stars that are relatively close to us. When the Earth is at one point in its orbit around the Sun, for example, in summer, we see a nearby star against the background of certain more distant stars. 6 months later, in winter, having moved to the opposite side of our orbit, a gigantic distance of about 300 million kilometers, we see the same star against a different patch of the distant cosmos. By measuring this tiny, barely perceptible angle of displacement, astronomers can calculate the distance to that star with high accuracy. But most importantly in this context, the very existence of this annual parallax irrefutably proves that the Earth revolves around the Sun and not the other way around, and that it is a moving body. The second phenomenon, similar but different in nature, is called the aberration of starlight. It was discovered and explained by the English astronomer James Bradley back in the 18th century. He noticed that the apparent position of all stars, without exception, shifts slightly throughout the year, and this shift is always directed toward the Earth's direction of motion in its orbit. This can be compared to rain. If you stand still in perfectly calm weather, raindrops fall vertically. But as soon as you start running, it seems to you that the rain is coming down at an angle, toward you. In exactly the same way, the light from the stars, which has a finite, albeit enormous speed, and the Earth, moving in its orbit at about 30 kilometers per second, combine vectorially. To see a star in the center of a telescope, we have to tilt it slightly forward in the direction of the Earth's motion. This angle of tilt is the aberration of light. This phenomenon is direct instrumental proof of the Earth's motion through space, which is an integral fundamental part of the model of a spherical planet orbiting the Sun. Let us descend from the celestial heights to our sinful Earth and talk about things quite terrestrial and even formidable: ballistics. When firing modern long-range artillery guns over great distances or launching intercontinental ballistic missiles, it is necessary to account not only for the strength and direction of the wind, humidity, and air resistance, but also for two other crucial factors: the curvature of the Earth and its rotation, that same Coriolis effect. At a distance of several tens of kilometers, the target will already be significantly lower than an imaginary horizontal line due to the planet's curve. If a correction for this curvature is not entered into the calculations, the shell will fly hundreds of meters above the target. Artillery tables and the highly complex computer systems for guiding ballistic missiles by default contain complex calculations based on the model of a spherical rotating Earth. Hitting the target is not a matter of faith or philosophy, but a matter of life and death in military affairs. And this supreme accuracy is achieved only by mandatory consideration of the fact that we are not firing across a flat firing range, but across the convex surface of a huge rotating sphere. Now, let us talk about how our Earth is structured inside. Seismologists, by studying earthquakes, gain invaluable information about the internal structure of our planet. When a powerful earthquake occurs, seismic waves propagate from its epicenter in all directions through the body of the planet, like ripples on water from a thrown stone. These waves are of different types. Some, longitudinal P waves, can pass through both solid and liquid mediums, while others, transverse S waves, can only pass through solids. Thousands of seismic stations located around the world register these waves. By analyzing their arrival times and their trajectories, scientists have been able to create a detailed map of the Earth's interior. They discovered that in certain directions, on the opposite side of the planet from the epicenter, S waves do not pass through, creating a so-called shadow zone. This led to the irrefutable conclusion that the Earth has a huge liquid outer core. The very fact that waves from an earthquake in Japan can be registered in South America, having passed through the entire body of the planet, proves its three-dimensional spherical structure. On a flat Earth, seismic waves would only propagate along its surface like across a giant pancake. Our world possesses another amazing, invisible, but vitally important feature: a powerful magnetic field. It acts as an invisible shield, protecting all life on the surface from streams of harmful solar radiation and allowing us to navigate with a compass. But where does it come from? According to the widely accepted geodynamo theory, the magnetic field is generated by complex convection currents in the Earth's liquid metallic outer core. The planet's rotation twists these flows of molten iron and nickel into giant spirals, creating a gargantuan natural electromagnet, which is essentially what our planet is. This model, which perfectly explains the existence and structure of a dipole magnetic field with two poles, north and south, is entirely dependent on the idea of a spherical, multi-layered, and rotating Earth. On a flat, stationary disk, it would be extremely difficult, if not impossible, to explain the existence of such a complex, symmetrical, and powerful dipole magnetic field. We've already mentioned that the Earth is not a perfect sphere, but a geoid, flattened at the poles and bulging at the equator. This leads to another subtle but quite measurable consequence. The acceleration due to gravity, denoted in physics by the letter g, is not an absolutely constant value across the entire planet. It differs slightly depending on geographic latitude. At the poles, where you are physically closer to the Earth's center of mass, the force of gravity is slightly higher than at the equator. There, firstly, you are farther from the center due to the equatorial bulge, and secondly, you are affected by the centrifugal force from rotation, which, in a way, makes you slightly lighter. These minute but real differences are measured using high-precision instruments called gravimeters. The map of Earth's gravitational anomalies, compiled from the results of thousands of measurements, fully corresponds to the model of a rotating oblate spheroid. This is another subtle but irrefutable physical proof, hidden in the very foundation of our world's physical laws. It sometimes happens that even the most ardent and convinced supporters of an idea prove its complete untenability through their own actions. Within the community of flat Earth theory proponents, there have been repeated attempts to prove their case with expensive experiments. One of the most famous and telling is the experiment with a high-precision laser gyroscope. This complex device is capable of detecting the slightest angular rotation. The experimenter's idea was simple: to show that the gyroscope would not register any rotation, which would irrefutably prove the Earth's immobility. However, when the experiment was conducted and the device was turned on, the high-precision gyroscope, to the astonishment of its owners, showed a constant drift of exactly 15 degrees per hour. This is precisely the angular velocity at which the Earth rotates on its axis, completing a full circle in 24 hours. Instead of disproving the rotation of a sphere, the experimenters unwittingly, brilliantly, and with high accuracy confirmed it. Let us recall another classic fundamental experiment from the golden age of scientific history, the famous Cavendish experiment. At the end of the 18th century, the English scientist Henry Cavendish conducted an incredibly delicate and complex experiment to measure the gravitational constant. He used an ingenious device, a torsion balance, to measure the infinitesimally small force of attraction between large and small lead balls in his laboratory. With this, he not only weighed the Earth for the first time in history, that is, determined its mass with high accuracy, but also visually demonstrated at a laboratory level the universal principle of gravitation itself, that any two objects in the universe with mass attract each other. It is this universal force, acting between all particles of matter, that causes large cosmic bodies such as planets and stars to gather into the most compact and energetically stable form, a sphere. The Cavendish experiment showed the very mechanism behind the formation of planets, confirming that the Earth is no exception to the general rule. And finally, let us look once more at the starry sky, this time from a perspective of millennia. As far back as the ancient Greek astronomer Hipparchus, by meticulously comparing his observations with data from earlier Babylonian astronomers, discovered an astonishing phenomenon called the precession of the equinoxes. He noticed that the vernal equinox, an imaginary point on the celestial sphere where the sun crosses the celestial equator moving north, is very slowly shifting through the zodiacal constellations. This shift completes a full circle in approximately 26,000 years. What does this mean on a physical level? It means that the Earth's axis of rotation does not maintain a fixed orientation in space. It slowly wobbles, describing a cone in space, much like the axis of a spinning top that is about to fall. Such precessional motion is characteristic of a massive rotating gyroscope, which is essentially what our planet, with its shape of a sphere flattened at the poles, is. A flat disk could not precess in such a complex and predictable manner. This slow, centuries-long wobble of the world's axis is another deep bass note in the grand symphony of the cosmos, and every note in this symphony says that our home is a rotating sphere. We have examined 32 completely different phenomena, from ships irretrievably sinking below the horizon and the round shadow on the moon, to complex GPS navigation and the optimal flight paths of airplanes, from different star patterns in different hemispheres to symmetrically spinning hurricanes, from ancient experiments with simple sticks to modern high-precision laser measurements. Each of these proofs is self-contained and completely independent of all the others. To continue believing in a flat Earth, one must not just reject them all. One must invent a separate, unrelated, extremely artificial, and contrived explanation for each one. One must believe that ships sink due to some complex and scientifically unknown optical illusion, that the shadow on the moon is from some invisible dark object in space, that the stars are different because of a bizarre refraction of light in the atmosphere, that GPS works by magic, and that hundreds of thousands of pilots worldwide are in on a conspiracy and intentionally fly strange and uneconomical routes. Or one can accept one simple and elegant explanation that harmoniously links all these 32 phenomena and countless others into a single, logical, and consistent picture of the world. The explanation that we live on the surface of a huge, beautiful, rotating blue sphere. The choice is yours.